Welcome learners in today's session, and today we are going to look at transformer. So we are looking at a transformer. So basically a transformer is a device that transforms or converts voltage from one level to another level. It will convert voltage from one level to another level. So a transformer is made up of two coils which are wound on an iron core, and we have what we call the primary core and the secondary core. So we want to look at how a transformer operates. So basically it operates in a way that when a charge or a voltage is applied across the primary winding, meaning the first coil, it induces an electromotive force in the secondary winding or secondary coil, which will be in such a way that it is opposing the one causing it. So basically transformers uses the concept of mutual inductance. So for any ideal transformer, the input power is always equal to the output power. Power in is equals to, or power on the primary is equal to power on the secondary, or Pi is equal to P out. Power in is same as power output. And you know very well power is equals to current of the primary winding, voltage of the primary winding is same as current of the secondary winding, voltage of the secondary winding. So that's how we can come up with that. Then you go to what we call the circuit symbol or diagram for the transformer. So the circuit diagram for a transformer, you just draw two coils. So you start with the primary coil, then you come up with the secondary coil that way. So that's a circuit diagram for a transformer. So here we have I power. I power means power on the primary winding. We can have resistance on the primary winding. We can also have what we call voltage. Voltage on the primary winding. We can have voltage on the secondary winding. We can have power or current on the secondary winding. Then you can have what you call power in. Then you can have what you call power out. Power out. So we want to look at types of transformers. There are two types of transformers. One is a step-up transformer. Step-up transformer is a transformer that has the primary windings are less than the secondary windings. The number of turns on the primary are less than the number of turns on the secondary winding. Step down, it means, so step up, it means these are transformer that converts a voltage from a lower level to a higher level. Converting voltage from a lower level to higher voltage. Then we are saying in this transformer, the number of windings on the primary coil are less than the number of windings on the secondary coil. The number of windings on the primary is the number of windings on the secondary. Then you can look at what you call voltage. So voltage of the primary is less than voltage of the secondary. Another feature of this transformer. We can look at current. Now current of the primary is greater than current of the secondary coil. But here power on the primary is same as power on the secondary coil. Then the second type of a transformer is known as a step up. This was a step up, sorry. Then you can go to step down. So step down is a kind of a transformer that converts voltage from a higher level to a lower level. We said for step up, it will convert voltage from a lower level to a higher level. But with step down is converting voltage from a higher level to a lower level. They want to look at the features of this particular transformer. So it means the number of windings on the primary are greater than the number of windings on the secondary. The number of turns of that coil, primary coil, are greater than the number of turns on the secondary coil. Another feature is the voltage. Voltage on the primary coil is greater than voltage on the secondary coil. The another feature is current. Current on the primary coil is less than current on the secondary coil. The last you have power. Power dissipated on the primary coil is equal to power on the secondary coil. So basically that's the features of that particular transformer. So for any ideal transformer, we are saying for any ideal transformer, power in same as power out. We have what we call transformer ratio. Transformer ratio is the ratio of change from the primary voltage to the secondary voltage. So transformer ratio is given that particular symbol, and we say transformer ratio is equals to number of turns on the primary divided by number of turns on the secondary. We take that. Then we say it's same as the voltage on the primary divided by voltage on the secondary, which is same as current on the secondary divided by current on the primary. So that formula we can use it to come up with what we call transformer ratio. Thank you.